Okay, good afternoon, class. So today we look at exponents and surds. So we're going to do the second part of the examples for exercise 1.3. So we looked at multiplying exponents, not so multiplying and dividing powers. So today we will be looking at adding and subtracting powers. Okay? So in adding or subtracting powers and unknown exponents, use the following method. Split the powers into unknown exponents. Split the powers with unknown exponents. So it's going to be a to the exponent n plus m can be written as x to the exponent m times x to the exponent n. Remember the rule that says a to the exponent m times a to the exponent n can be written as a to the m plus n. That's the first rule of exponents. So now we're working it in the reverse basically. Okay? Factorize by taking out the common factor. Okay? So this is example 1 and this is on page 7. Example 1 is on page 7. Okay. So we got 3 to the exponent n plus 3 to the exponent n plus 1 over 7 times 3 to the n. So in the previous lesson we could have moved that down, not so, but we can't do it in this case. Why? It's not the multiplication, it's the addition between the two terms in the numerator. Can you see that? There's a plus there. So what we need to do is, we need to break this up and then we're going to factorize what is common there. You guys understand? This will be written as 3 to the exponent n plus 3 to the n times 3 to the 1. And this is all over 7 times 3 to the n. Okay. So now what do we do? Take our 3n as a common factor. Okay, we're going to take our 3n as a common factor. But take it out, what do I left with? 3 to the n into 1 plus 3 to the 1. And 3 to the 1 is what? 3. This is all over 7 times 3 to the n. Okay. Now what do we do? What do we cancel? 3 to the exponent. So let's cancel that. And what is 1 plus 3? 4. It will be 4 over 7. See any confusion there? Okay, you all understand. Let's look at example 2. Example 2 is on page? It's on page 7. This is examples for exercise 1.3 on page 8. Okay. So what do we do here? Again we're going to break up. Again we can't take that down to the numerator, not so. Or that, sorry, take this up to the numerator. Or take 5 to the n minus 1 down to the denominator. Why? Because of that minus between them. You all see that? So what I'm going to do is I'm going to break it up and then factorize. So 5 to the n plus 1 can be written as 5 to the n times 5 to the 1 minus. This can be written as 5 to the n times 5 to the negative 1. And this is all over 2 times 5 to the n times. Okay. Now what? With a common factor of what? 5 to the n. You take out 5 to the in, what we left with? 5 to the 1. Minus 5 to the negative 1. And this is all over 2 times 5 to the n times 5 to the n. Now what? You cancel 5 to the n. Okay. So 5 to the minus 1 is what? 1 over 5. So it's 5 minus 1 over 5 over what? 2 times 1 over 25. Or 1 over 5 squared. Not so. Now what is 5 minus 1 over 5? This is going to be 25 minus 1 is 24. So it's 24 over 5. Not so. What does this line mean? Divided. So that's divided by 2 over 25. Not so. But 2 over 25 can be written as what? If we say, sorry, 24 over 25. If I change that to multiplication, what do I do? Now becomes 24 over 5. You multiply it by 25 over 2. Now what do we do? 5's cancels, yes? 5 into 5 once, 5 into 25. 5 times. 2 goes into 2 once, 2 goes into 24. 12 times. Okay. And what's 12 times 5?
60.
60 over 1, which is 60. Was there any confusion there? You will understand. You will understand, people? Okay. So with that, you should be able to do exercise 1.3. Okay.